A question that sometimes aches my brain, but I think is a question that's likely to be asked more. I do get this question sometimes, which is the convergence of quantum computing and AI. How real is this, and what are the downstream implications? So how I see this is that the convergence in many ways of quantum computing and AI is indeed beginning to take shape. But I would say in the larger context, I would consider this still an area for future development. Currently quantum computing remains in what we could sort of say is a relatively nascent stage, with real practical or large-scale applications, in many ways still out of reach due to technological hurdles, such as error rates and qubit coherence times. Those are sort of also hampered by the overall physiological and physical challenges that exist in building these quantum systems. However, the potential for quantum computing to truly revolutionize AI and vice versa in a lot of ways is substantial and is actively being explored in research and some niche applications. So let's talk about where that convergence can happen, the convergence between quantum computing and AI. First is around speed and efficiency. So quantum computers can theoretically process complex computations much faster than classic computers. And they do this by leveraging phenomena like superposition and entanglement. And this can drastically reduce the time required for tasks such as training deep learning models or optimizing AI algorithms. The second area is the enhancement of machine learning models. So quantum algorithms have the potential to improve machine learning models by enabling them to handle computations that are, generally speaking, intractable for classic systems. This includes faster processing of linear algebra operations, which quite often is fundamental to many AI algorithms. So another area is quantum annealing for optimization problems. Quantum annealing is a specific approach designed to solve optimization problems more efficiently than classic computers. Now, this has implications for AI fields that require complex optimization, such as logistics or even scheduling tasks. The issue around explainability. Now, quantum computing does add another layer of complexity to this already challenging issue of AI explainability. The inherent probabilistic nature of quantum mechanics in many ways makes the interpretation of quantum algorithms and their outcomes less intuitive and more complex compared to classic algorithms. Now, here's how one might impact or see quantum computing impact the explainability challenge. First, there's the inherent complexity, right? So quantum states and operations do not have direct analogs in classic computing, making them far more difficult to understand without a deep background in quantum physics. This could make it challenging to trace decision-making processes in AI systems that are powered by quantum computers. Probabilistic outputs, that's a challenge, right? So quantum algorithms often deal in probabilities rather than definitive values, which could complicate efforts to pinpoint why certain decisions or predictions were made, thus making the reasoning process less transparent. There's the broader challenge around tool development. So tools and frameworks that can aid in the explainability of quantum enhanced AI are still underdeveloped, in many ways do not exist. So developing such tools will be crucial to ensure that quantum AI systems adhere to ethical standards and require transparency. So in summary, while the convergence of quantum computing and AI holds promising potential, and we're beginning to see some very early stage applications, adoption is still a future prospect. Additionally, I think this convergence will likely make the challenge of explaining AI decisions more complex, and that in many ways will necessitate new approaches and tools to ensure transparency and understandability in these AI quantum systems.